of x minus 2 must be less than epsilon. And what does this tell us? This tells us that the absolute value of x minus 2 must be less than, okay? If we divide across by the absolute value of 3, we get epsilon over 3. So what we've just found here is this, is that we found some number, okay? Don't forget, epsilon is greater than 0, so this number here is also greater than 0, okay? So we found some number greater than 0 such that x minus 2 is less than that, okay? So let's choose, so now what we're going to do is this, is that let's choose delta to be equal to epsilon over 3. So let's choose this now. And let's now take the premise, okay? So let's now consider the premise, and let's see from the premise, can we get the conclusion, okay? So we've now found the appropriate delta, and let's see with this particular delta, do we end up with this particular conclusion? Well, what does the premise tell us? The premise tells us that x minus 2 must be less than delta, and we've just chosen delta to be epsilon over 3, okay? And what does that tell us? That tells us that minus epsilon over 3 must be less than x minus 2, which must be less than epsilon over 3. Multiplying across by positive 3, that gives us minus epsilon must be less than 3 times x minus 2, which must be less than epsilon. Okay, multiplying right across by the positive 3. Okay. What does this give us? This gives us that minus epsilon must be less than 3x minus 6, which must be less than epsilon. So we've now got an absolute value here that's less than an epsilon, but we really need an epsilon where our conclusion has to be of this particular form here. So actually what you can actually see is that minus 6 is the same as plus 4 minus 10. So what we end up with here now is this, let me just move this up here a little bit. Okay? What we now end up with, okay, is that minus epsilon is less than 3x plus 4 minus 10, because plus 4 minus 10 gives us the minus 6, which is less than epsilon. Which, what does that tell us? That tells us that the absolute value of 3x plus 4, the function, minus its limit, the 10, is less than epsilon. So what we've now done is this, is you can see that by choosing the appropriate delta value, and that's what the game is all about, is that if someone gives you an epsilon greater than 0, that we should be able to find delta greater than 0, such that all the x within this particular region implies that the function minus the limit is less than epsilon. Right? And exactly what we got here, so choosing the delta to be equal to epsilon over 3, okay, how did we find that? Well, we found it by considering the conclusion and working through the conclusion to find something that looks like the premise of the implication. So choosing delta is equal to epsilon over 3, and now working this fact out here, what we arrive at is our conclusion. So this actually here is our x minus a is less than delta. We've found our delta, and what we do is we work that through until we deduce that f of x minus L is less than epsilon, which we've just shown here. Okay, guys, I'll do another one of these just to hammer home this particular process, and then we'll move on to something a little bit more complicated, maybe quadratics. Okay. So once again, guys, this is Jonathan Lambert with Maths and Stats, and I hope that this video was in some way intuitive, and more importantly, I hope that was helpful for you. And thanks for watching. Okay, bye bye.